Hey guys! Today we're going to be talking about gravity. Gravity is one of the fundamental forces of the universe. It was discovered by Sir Isaac Newton, and it is what keeps the moon rotating around the Earth. It keeps the moon and the Earth rotating around the sun, and it keeps the moon, the Earth, and the sun rotating around the supermassive black hole at the center of our galaxy. More about that for those of you who stay for next year. But how exactly does gravity work? In this video, we're going to be discussing the equation that gravity runs by, as well as talking about some misconceptions about gravity. So let's start with the equation. Hopefully you guys recognize this from your lab. The force of gravity here, the force of gravity is equal to some constant g times the mass of one object. So this is going to be that mass of object 1. Now, conventionally, the capital M refers to the heavier mass. So if we're talking about the gravitational force between you and the Earth, this will be the Earth. And little m, object 2, is going to be your mass. So that'll be the mass of the smaller object. Finally, that is going to be divided by the distance between the centers of mass of the two objects. So I'm going to just call that distance between M1 and M2. Now, in your equation, you had hopefully this relationship between the force of gravity, the mass of object 1 and the mass of object 2, and the distance between mass 1 and mass 2. However, you didn't actually solve for that constant. So I'm going to go ahead and give you the value of that constant, and it is very small. G is equal to 6.67 times 10 to the negative 11th. So that is going to be the constant that you multiply the masses of both objects by to figure out the force of gravity. Now, the key idea here, guys, is that all masses are attracted to one another. So you are attracted to the floor, you are attracted to your pencil, and you are attracted to the person sitting next to you. Now, this force is going to be very small because remember, G equals 6.67 times 10 to the negative 11th. That is a very small number. And so you have to have a lot of mass in order to have a significant gravitational attraction, which is why you feel an attraction to the Earth, but you don't feel an attraction to the person sitting next to you. Now, before I discuss how to solve problems, I want to clear up one common misconception about gravity, specifically about what the distance between two objects is. This here is not the distance between mass 1 and mass 2. Why? Because that is not where their centers of mass are. We need to measure our distance from the center of mass of object 1 to the center of mass of object 2. So, the force of gravity between you and the Earth is not just going to be the distance between you and the surface of the Earth. It's going to be the distance between you, right here, there's you, and the center of the Earth. So just keep that in mind as you are solving problems, guys. The distance from the center of the Earth to its crust is going to affect the force of gravity much more significantly than how far away you are from the Earth's surface, because the Earth is much, much bigger even than Mount Everest. Okay, guys, so you know just about all there is about gravity. So hopefully you have enough information to fill out the notes that I've asked you to fill out. And now it is time to go on to the second video that is linked and go ahead and start solving problems.